is on simplifying radicals. A radical is it looks like this, and in this case, we're dealing with square roots. Remember that, if you don't already, remember that a square root is when you are finding a number multiplied by itself to give you the number that's in the radical. So for number 1, the square root of 36, you need to think of what number multiplied by itself would be 36. Aaliyah? 6. Okay, so the square root of 36 is just 6. Okay, number 2, the square root of 9 then, Nicholas, would be 3. Very good. Number 3, the square root of 25 is 5. Okay, very good. These are easy, right? The square root of 64 is 8. And the square root of 100?
10.
Good, it's 10. Sometimes students will say 50. They want to cut things in half. Taking the square root is not dividing by 2. Okay? It's what number multiplied by itself is the number inside. 10 times 10 is 100. 8 times 8 is 64. 5 times 5 is 25. Okay? Now, something that you're going to let me do it on the next page. We're going to want to make a list of what are called perfect squares. Okay, so when you look at number 6 and we say, okay, well, the square root of 12. Well, there is a number multiplied by itself that's 12, but it's not going to be a whole number. It's going to be a decimal. Okay, and so we could calculate that. There are ways you can come up with that. We could estimate it. You could type in your calculator, obviously, if you were allowed to use calculators, but we're not using calculators on this. So what we would do in this situation is we're not wanting to look for a decimal. We want to break this down. We want to simplify it. So out to the side of your paper, let's make a list of numbers that are perfect squares, okay? Numbers that you can take the square root of. And the way I usually come up with that list is I say, okay, 2 times 2 is 4, okay? Because if you multiply a number by itself, then you could work backwards and take the square root of that number, right? And you'd just be right back to 2. All right, so 3 times 3 is
9.
4 times 4,
16.
5 times 5,
25.
Are you writing this down?
Yes.
6 times 6,
36.
7 times 7,
49.
8 times 8,
64.
9 times 9,
81.
10 times 10,
100.
11 times 11,
121.
12 times 12.
144.
When's it going to stop? It's not, right? It's going to go on to infinity. Okay, that's pretty close to being, that's a good distance, so that'll be good for us. If we needed to go further, we could add to our list. Okay, so what you're going to want to do with number 6 is you want to try to figure out what is the largest perfect square that will divide into 12.
4.
No, the largest perfect square that will divide evenly into 12. No, the largest perfect square that will go into 12. It was 4. You were right. Some of you said 4. Yes. Okay, so what you're going to want to do is we're going to want to break this 12 down into a perfect square times something else. And that something else isn't going to be another perfect square. So 4 times what is 12? 3. 4 times 3 is 12. Okay. So first of all, you ask yourself, is 12 itself a perfect square? No. All right, so that's why now we had to go this route. And we said, okay, well, let me pick the largest perfect square that can divide into 12, and that was 4. 4 times 3 is 12. Then what you're going to want to do is you can take the square root of 4. You know that 4 is a perfect square, right? Okay, and here's a little silly way that I like to kind of explain this. This radical is kind of like jail, okay? And the only way to get out of jail is if you are perfect. Okay, now really, nobody can be perfect, but in this scenario, a perfect square, right? Now, if you're in jail, obviously you haven't made good choices. So when you get out of jail, hopefully you're going to make good choices, right? So you're not going to be the same that you were when you went in, right? So we're not going to bring this 4 out and it still be a 4. The square root of 4 is what?
2.
2. He's a new person, right? Okay, now that 3, poor thing. He's not a perfect square, so he has to still stay in there, or she has to stay in there, right? Okay, so we write it like this. We leave her in there just like that. So the answer looks like this. It's 2. The way you read it is 2 square root of 3. It means 2 times the square root of 3. Now, the square root of 3 is going to be 1 point something. So 2 times 1 point something is just going to be another decimal. And we don't want decimals. We want to simplify the radicals such that we, that way if there's a perfect square inside, we want to take it out. So we were able to break down the 12, take out a perfect square, and now we're left with 3. And 3 can't break down any further. I mean, 1 times 3, those are the only factors. Okay? So let's do a few more of those, and you're going to get good. You're going to get quicker at these. Okay? Yes?
Is there a way to like check it?
Check it. Well, the way you could check it is you could square that number right there, which would be 4, put it back in here, times it by that, and see if you get your 12 again. That's the only way that I would, but you could do that. You could do that. All right, so let's look at 7. So 200, is 200 a perfect square? Is there a number multiplied by itself that is 200? No. So then we want to say, okay, well then let's try to break it down. So look down your list and see if there is a number, the largest number on there that can go into 200. 100. Very good. So 100 times what?
2.
Times 2. Good. Okay, 100 times 2 is 200. Now, who's the perfect one in there?
2. 100.
The 100, the one off your list.
Yeah, 100.
He's the perfect one. So he gets to come out of jail, but when he comes out, he's not 100 anymore.
He's a 10.
He's a 10, right? He's a perfect 10, right? Okay. So he's a 10 because 10 times 10 is 100. Okay? But the 2, the square root of 2 is not a whole number. That's why it stays in there. Okay? So we leave it like this. So 10 square root of 2, or 10 times the square root of 2. Starting to get it?
How would you write the rule?
How would you write the rule? Like
how to remember it by?
Well, if it would be easier, maybe after you write this step right here, 100 times 2, if you prefer to write it this way, in 2 separate radicals, and then say, okay, well, the square root of 100 is just 10. Just 10. It's not square root anymore. It's just 10. And then this one isn't a perfect square, so it stays out. That's the best I can tell you for right now. Okay. All right, number 8, square root of 75. Is that a perfect square? No. So we're going to break it down. What's the number off my list that can go into 75? 25 times 3. Very good. Who gets to come out of the radical? 25. He comes out as a 5. And what's left inside?
3.
3. 5 square roots of 3. Very good. Okay. Number 9, don't let that negative throw you. That's really just a negative 1 times square root of 8. So we're just going to ignore it for right now. Okay, and we're going to, the square root of 80 is not a perfect square, so we're going to break it down into what? What is the largest number? Remember, no calculator, so if you have to go out to the side and calculate by hand. 4 will work, but that's not the largest one. 16 times what? Yes, Nicholas? 5. 16 times 5. 16 times 5 is 80. All right, now don't forget this out here. Okay? Now, the 16 is the one that gets to come out, and when it comes out as a
8.
No.
Negative 4.
8 times 8 is not 16.
4.
4 times 4 is 16. So it comes out as a 4, and because there's already a number out here, you have to multiply it. So when you pull the number out, if there's already a number out there, you multiply. So that's going to be negative 4, and then square root of 5. Okay? All right, so this one, 27, we're going to need to break that down into 9 times 3. The 9 comes out as a 3, but there's a negative 1 out there, so it's a negative 3, right? Square root of 3. Very good. Any questions so far? You're doing wonderful. We're good back there? Okay, awesome. Okay, adding like radicals. So adding like radicals is like adding like terms. 5x plus 6x is 11x. So therefore, 5 square root of 2 plus 6 square root of 2, the radicals have the same number inside. So you are allowed to add the numbers in front together. 5 and 6 would be 11, square root of 2. You don't add the 2's. Okay, so let's apply that. So for number 11, do they have the same number inside the radical?
Yes.
So we leave the radical alone, square root of 2, and add the numbers in front. 10. 10, square root of 2. Okay, number 12, what would this one be?
7 square root of 3.
7 square root of 3. Very good. How about 13? What are your thoughts here?
You have to find the
You have to break it down first. They're not the same inside, so there's no way we can add those. And by the way, what number is out here if we don't see a number? A 1. Just like when we're talking about the variable x, we don't have to say 1x. We know it's just x. Okay? So let's break down the 18. What can it break down into?
9.
Yes, 9 times 2. Okay, the 9 comes out as a 3, so we have 3 square root of 2. Bring down the plus sign. Break down the 27 into 9 times 3. Good, Chill. Bring up the 9 as a 3. What's left inside? 3. Can we add those together?
No.
No. One has a 2 inside. One has a 3 inside the radical. So guess what? This is how you're going to leave your answer, just like this. Yes.
Let's say like whenever we if it's like it. So you see how we did 9 times 3 and then 9 times 2. Like they can be whatever numbers we need to make it simplified, right?
Well, make sure that the number that one of the numbers you choose has to be on your list of perfect squares. So even though 6 times 3 is 18, 6 isn't a perfect square, and neither is 3. So you wouldn't want to use that pair. It needs to be off of your perfect square list, and it needs to be the largest number down the perfect square list that will work. Okay?
Are there gonna be on our homework any circle squares that like we need to do that are more than 12?
I'm not sure that there are, but if there are, just extend your list. 13 times 13 and write it down, which is 169 if you want to add to your list. Okay, 14. So let's do the same thing here. Break down the 20 into what?
5 times 4.
Good. 4 times 5. Which one's the perfect square?
4.
The 4 comes out as a
2.
2, square root of 5. Bring down your plus sign. The 45 breaks down into 9 times 5. Which one's the perfect square?
9.
The 9 comes out as a 3, square root of 5. Okay, so
5 square root of 5.
very good, because they have the same number inside. You can add 2 and 3 and get 5, square root of 5. Very good. Okay, the next one, square root of 27. 9 times 3. The 9 comes out as a 3, square root of 3. Bring down your plus sign. The 12.
4 times 3.
The 4 comes out as a 2, square root of 3. Can you add those together?
Yes.
5, square root of 3. Very good. Okay, subtracting is going to be the same way. Same rules, okay? Do we know the square root of 50? Is it a perfect square? No, it's not. So we need to break it down into,
5 times 10.
okay, 5 times 10 is 50, but 5 and 10 are not on our list.
squares.
25 times
2.
2. I'm actually glad you guys said 5 times 10 because I gave us a reason to discuss that. Remember, it has to be a number that's a perfect square. Okay, so 25 comes out as a 5, square root of 2, minus, break down the 18 into 9 times 2. The 9 comes out as a 3, square root of 2. Now, what do you think?
2 square root of 2.
Oh, very good. 5 minus 3 is 2. And then square root of 2. Very good. Okay, 48. Is it a perfect square?
No.
Is there a number times itself that's 48? No. So 4 times 12 is 48. Can I use that? I could, but it's going to, it won't be all the way simplified. So what do you think? Chael, I think you might have it.
8 times 6.
Oh, no, sorry, I thought you said something different. 8 times 6 is 48, but 8 and 6 aren't perfect squares. Michael?
16 times 3.
Yes, 16 times 3. Okay, the 16 comes out as a
8. No, 4.
Okay, when you do your homework, go slower, okay? Comes out as a 4. Remember, it's the number times itself. And then you have your 3 left inside. Minus 27 is 9 times 3. We've done that already, haven't we? That becomes 3 square root of 3. And then what's my answer?
1 square root. So this square root.
Right. We don't want to write it like this. 1 square root of 3 because 1, that means times, right?
Yes.
So that's not all the way simplified because 1 times anything is always that other number, right? Which is just square root of 3. Awesome. You guys are doing wonderful. Okay, next. Multiplying radicals. The square root of x times the square root of that same number is going to just be x. Let me show you. The square root of 4, for example, times the square root of 4. 4 times 4 would be square root of 16, and the square root of 16 is just 4. So based on that, you know that the square root of number times the square root of that same number is just the number inside. Based on this. Okay? So the square root of 8 times the square root of 8 is 8. The square root of 112 times the square root of 112 is 112. Okay, that's an easy little rule to remember. Okay, this is why, right here, but it saves you some steps. Okay, next, so we don't have that same thing happening here in 20. So we're going to multiply those together. So 6 times 3 is 18. Do we know the square root of 18? This is a perfect square. No, it's not. So we need to break it down. It can break down into 9 times 2. Very good. The 9 comes out as a 3 square root of 2. Okay, so there's a difference here when you're doing multiplication. When you're doing multiplication, you want to multiply the numbers inside the radical first and then break down. With addition and subtraction, you needed to break down first to get it all the way simplified before you could determine if you were going to add or subtract them together because they had to have the same number under the radical. Okay? All right. Next, square root of 10 times square root of 40. Square root of 400. Is that a perfect square?
Yes.
Zach says yes. He's right. It's 20. 20 times 20 is 400. So you don't need to break that down. The answer is just 20. Square root of 400 is just 20. Okay, the next one. Square root of 7 times square root of 21 is the square root of 147. Very good. You might need to think about that one for a minute.
It's odd.
Well, see if you can think of a number from your list that can divide into 147 because it isn't a perfect square, so we're going to need to break it down. Haley, do you have it? Oh, I thought your hand was up. 49 times
3.
yes. 49 times 3 is 147. Okay, so the 49 comes out as a 7 square root of
3.
3. Very good. Okay, now if we have numbers in the front, we're just going to multiply those together first. So 3 times negative 2 is negative 6. Square root of 8 times 2 is 16. Now let's simplify that. Square root of 16, we know what that is.
4.
Comes out as a 4. Oh, there's already a negative 6 out there. What do? I multiply them. We've talked about that already. So my answer is negative 24. I don't know, but that's all right, 24. What should we do here? Nicholas? Multiply everything. Yeah, we're going to square it. My suggestion is that you write it out twice. 2 square root of 3 times 2 square root of 3. And then do what we just did. So we multiply the numbers in front. 2 times 2 is 4. Now we could do square root of 3 times square root of 3 and write square root of 9, or we could apply the rule that we just discussed a minute ago, and any square root of a number times the square root of that same number is just the number inside, right? So the square root of 3 times the square root of 3 is just 3. 3. No, it's not square root of 3, it's just 3. So 4 times 3 is 12. Now, if you prefer to write it this way, 4 square root of 9, and then show the 9 comes out as a 3, and then multiply. I don't care how you show it, okay, as long as you understand. Was that the last one?
Yes.
Okay. Is that 5-4?